I'm sure most of you already know about ACAN and some are already involved in the network, but for the benefit of others in the room, I'll give a brief introduction into who we are and what we do before we jump into hemp. So ACAN stands for the Architects Climate Action Network. We're a voluntary open source collaborative network of individuals in the built environment industry working to combat the twin crises of climate and ecological breakdown. Although individuals, we come together around these three aims. We're working to decarbonise now. The next few years will be crucial in limiting climate change, and as an industry, we need to radically transform the regulatory, economic and cultural landscape in which we operate to significantly reduce our carbon footprint. I'm sure you're already aware that about 38% of the UK's CO2 emissions are attributed to the built environment. But transformation is not complete without fundamentally readdressing our relationship with nature, regenerating biodiversity and establishing a new regenerative coexistence with the planet is essential. And neither of these two goals will be achievable without a ground-up cultural transformation and systemic change. We need to challenge how the built environment can not only do less harm, but also be a force for positive good. ACAN currently has 9 thematic groups. So next slide, yeah. These range from circular economy to embodied carbon to carbon literacy. If you're interested in joining us, you can find out more on our website, architectscan.org. And I'm sure someone just put that in the chat. We hope tonight inspires you to take part. Finally, before we get on to the main event, ACAN is an entirely voluntary organisation. We take no sponsorship and we rely on donations for our overheads to put on events like this. If you haven't donated already, please do consider it. And I'm now going to hand over to Emma to kick off with hemp.
Thank you, Steph. We're so glad to welcome everyone to this next event in our series of masterclasses in building with natural materials. Building with natural materials, as I'm sure you all know, is one of the most powerful ways in which we can transform the built environment industry from being damaging and carbon intensive to something that's regenerative and truly restorative for our climate and ecologies. We need to be looking not just at how we can reduce the damage that architecture, engineering and other built environment professions are causing, but also how we can actually be a positive force restoring the damage that we've already caused to our planet. Tonight we are focusing on hemp. A couple of fun facts for you. Hemp is one of the fastest growing species on Earth, along with bamboo, and it has over 25,000 useful end products, from paper, textiles, rope for ships, medicine and oil, amongst many, many other things, some of which we're going to hear about tonight. It's estimated that for each tonne of hemp fibre grown, 2 tonnes of CO2 are absorbed and sequestered. It's 6 times as strong as cotton, and in the 16th century, Henry VIII even made hemp cultivation obligatory as he wanted it for the production of rope. It can take as little as 100 days for a hemp plant to be ready to harvest, and it can be grown all year round in the UK. It doesn't require any artificial fertilizers or pesticides, which makes it a fantastic break crop for farmers to alternate with other forms of agriculture. You currently need a government license to grow industrial hemp, but things are improving. In recent years, low THC cultivars have been bred, which is helping to bring this super sustainable crop into the mainstream. So we're really pleased to be joined tonight by such an exciting panel of speakers. First up, we're going to hear from Will Stanix. I think it sounds like pretty much every hemp project in the UK has been touched by Will at some point. He's going to give us an intro to the opportunities of the material and a bit of an insight into his own personal experience building with hemp. Next, we're going to move to France, across the channel, and hear from Sonia Soufflet from Le Mot. They are an architectural studio based in France who recently completed France's first ever hemp block building. So we're going to hear more about her experience working with a collaborative team to forge this path. Next, we're going to move to Alex Sparrow, another megalith in UK hemp construction. He co-authored the Hempcrete book, Designing and Building with Hemp Lime, along with Will, and he's going to tackle some of the biggest benefits and myths surrounding hemp construction. And then we're going to finish with Paloma Gormley, who's an internationally acclaimed designer. We're going to hear about her work with practice architecture and material cultures, working to bring hemp-based prefabrication to the mass market. Can't wait to get started. But one final thing before we kick off with this fantastic panel, we have a really quick poll. The intention of this is it will help us understand who attends our events and what impact we're having. So I'm just going to stop sharing and launch the poll. And that's it. Brilliant. Thank you everyone so much for your responses. There it is shared. If you want to have a quick scroll through, we'll also take screenshots and we'll share those and we can circulate them. But I'm now going to hand over to our first speaker and we can get going tonight for real. So Will, the floor is yours.
Hey, can you hear me now?
Yeah, loud and clear. We had you up on screen for a second, but it seems to have vanished now.
Right, I'll try. I'll do it again. It won't take me a second.
Thank you.
And we're off.
Beautiful.
Right. Hello, and thank you for inviting me back for a second event. I'm going to be talking a bit about cast hempcrete, sprayed hempcrete blocks, and the differences between them. I'm going to move quite quickly because I've got a bit to get through. I started, as most contractors do, with cast hempcrete. The line binder and hemp shiv are mixed together with water, and these are all examples of mixers that will mix cast hempcrete on site. You mix the ingredients together, which doesn't take long, and out comes the hempcrete, which you take in buckets to the shuttering, and in it goes. A light spread around and a prod, and you're ready for the next bucket load. You have a choice of where to put the structural frame. In the left picture, it's placed centrally. In the middle picture, it's to one side, which could be internally to take heavy fixings or externally to take cladding. And in the right-hand picture, it's placed slightly off-center towards the outside, which was dictated by the plinth design. The hempcrete with a frame centrally or slightly off-center needs no extra support. It's engulfing the frame and can't move away from it. When the frame is to one side of the wall, the hempcrete could effectively be forced away from the frame. So as a precaution, you can see in the middle picture there are horizontal battens placed at 600 to 800 mil centers, which provides something for the hempcrete to cling onto. The shuttering is usually OSB. It's set up like so. It's filled, then the same shuttering is moved up the wall to continue the work. The spacers cut from waste pipe are also moved up the wall as work progresses. Shuttering can also be one of the purpose-made shuttering systems. This one that I use is extremely easy and quick to use and very solid. My favorite thing about cast hempcrete has got to be how easy it is to plaster or render onto. It's such a nice surface to put finishes on. It's overall very flat, but also extremely textured for the plaster to cling to. And there's just the perfect amount of suction or water absorption from the hempcrete so that you can progress quickly, but without having to rush. This is one of my favorite builds, which I rendered all by myself, and I thoroughly enjoyed every second of it. This one shows that curves are possible, and again provide an excellent surface to plaster onto, as can be seen by the internal lime plaster. A misconception with cast hempcrete is that you have to tamp it with a stick. This is not actually necessary, and it's more efficient and easier and gives better results if you use your hand. The key is not to pour too much in at a time. So you should spread one gorilla tub between about 3 of the spaces between the studs, then spread it around with your hand and give it a prod around the timbers and around the shuttering, and that's it. Cast hempcrete is beautifully simple, but there's a lot of labour involved. And as a contractor, it becomes difficult to continue to get the casual labour you need and to manage it when you do get it. This for me was the main driver to start looking at spray machines. Now, it would be very unfair of me to talk about sprayed hempcrete without first mentioning my good friend Graham Durrant of Hemp Lime Spray, who's put more hempcrete into buildings in the UK than the rest of us hempcreters put together. He's taken spraying here from its early days of basically trying to figure out how the bloody hell these machines work to the efficient and effective solution it is now. And he's been kind enough to share all he's learned with myself and many others. Graham's the UK agent for these French machines, 3 of which reside in the UK, and that's me on the left picking mine up. It's a very compact machine and tows behind a van. On the right, it's set up ready to spray, and we make a sort of tray beneath it at a geotextile that retains all the spilt lime but lets water through in an attempt to keep the site as tidy as possible. It's a pretty nifty machine. On the left there, the lime and water is mixed in the large drum. I'll see if I get my mouse to. The lime and water is mixed in the large drum, and then that's tipped over into the pan mixer, which keeps it agitated until it's ready to be pumped up the hoses. The middle picture is the hemp box, which gets filled with hemp shiv, which is then blown dry down the hose to the nozzle or lance. So traveling down these hoses on the right, you have dry hemp in the white hose, lime slurry in the black hose, and the blue is for compressed air, and the red is the electrics for the control switch. The hemp and binder mix in the air between exiting the lance and hitting the wall or substrate. The binder is forced out of 3 nozzles by the compressed air, and the nozzles are angled in towards the central stream of dry hemp, as you can see here. Although it can get messy if you're not careful, it's actually quite controlled, and you can see there how close Jamie's boot is to the lance, and he's not getting covered. Just as in cast hempcrete, if the frame is central, you need no further support. But if the frame is to one side, as in this build, then you need some extra battening for the hempcrete to cling onto and avoid any possibility of it separating from the frame. Shuttering for sprayed hempcrete is very quick and can be as simple as hessian pinned to one side of the frame. The hempcrete is then sprayed onto the hessian. This is left overnight, then the next day the hessian is peeled away, as in the middle picture, and the rest of the hempcrete is then sprayed from the other side of the wall at the previous day's work. The shuttering can also be cardboard. This is an existing old roof. The left picture is from the underside, where I have a stapled card to the underside of the old roof battens. The middle picture is from the outside looking down on the roof, half of which I've sprayed, and you can see the card on the other half. And the right-hand picture is again from the underside, but with the card removed, and you can see the hempcrete. The old rafters will be left exposed and the hempcrete plastered. These pictures just show that roof in a bit more context. Once you're happy that you're near enough flat with your walls, you get a long piece of wood, which you've banged lots of nails into to make a long and very technical scratchy stick. Graham Durrant currently has patent pending on the scratchy stick. You run it over the wall using predetermined guide rails that you've sprayed into the wall, one at the top and one at the bottom. If you're doing an old place with wonky walls, you can spray freehand and just tidy it up at the end with a nail float so you can keep the original contours of the wall. Some people assume you cannot spray crisp corners and flat walls. These are a couple of sprayed window reveals on a recent build that disprove this. Spraying can create a lot of drop. This is hemp that has hit the background and bounced out into the floor. Different jobs create different amounts, and a deep, thick wall creates hardly any as it drops into the wall and gets sprayed in, whereas a thin wall can create a fair bit. However, it does not have to be waste. You can see on the right we're spraying a building, but there's a small yellow pan mixer and one wall of shutter set up on the left-hand side of the room, just there. All the drop is collected and cast into the shuttered wall. And what's more, because you have a spray machine on site, you don't have to cast the top of the wall where it's awkward and would take a long time. You just remove the shutters and spray the top bit, as I'm doing in the not very good picture on the left. Sprayed hempcrete can reach places that cast hempcrete can't. This building on the left is set into the hillside, and that tiny wall was sprayed with the roof on and tiled. The density of hempcrete is controlled by turning a dial, so you can switch between different densities of mixes very easily. Sprayed hempcrete is no quicker than cast hempcrete, but it does take a lot less labour, and it removes the need for carrying gorilla tubs, and in my experience, it dries quicker. These are just a couple of examples of some sprayed hempcrete buildings. Over to blocks. These were the first hempcrete blocks to roll off the production line at H.G. Matthews in Chesham. And you can see how excited I am about that. and how not excited Steve is. I set up production there a few years ago and it was pretty successful, but unfortunately they've had to scale back during the pandemic and are not currently producing UK blocks, although their website is worth a look at for clay blocks and other natural materials. They are, however, the main stockist for the Italian blocks imported by the Hemp Block Company, the idea being that as soon as there is enough demand, they will start up production again using the Italian recipe under license. The main drivers for using blocks are that they are already dry and they're non-specialist. Anyone can use them and the tools are very simple and widely available. It's basically hempcrete for the masses. The mortar is a lime mortar. It can be mixed in a cement mixer just like sand and cement, but it's sand and lime. Pretty much any lime mortar is suitable, and if you're using the giant blocks, which have a mortar line straight through the wall, you can use an insulating mortar, which has lightweight aggregate instead of sand. The blocks are tied back to the frame using stainless steel timber ties, just like the picture on the right, just like you would tie a masonry facade back to a timber frame. The blocks are cut very easily with a hand saw, or as shown here, an alligator saw, which can do some quite elaborate cuts. Here are some different wall sections, courtesy of the Hemp Block Company and expertly drawn by Anniko Hegedus. On the left are the giant blocks in combination with a portal frame. So the blocks sit outside of the frame and they basically make up the whole wall. They're rendered or clad on the outside and plastered on the inside. On the right there is two skins of blocks, either side of a stud frame, and the stud frame is filled with lightweight insulation such as wood fibre or hemp bats. On the left of this slide, there are blocks on one side of the frame again with a lightweight insulation in the middle and cladding on the exterior. On the right is a similar build-up, but with wood fibre bores screwed to the exterior so they can take a render. And you can find all these sections you can download from www.hempblock.co.uk. Blocks with a portal frame is my favoured way of using them. It's incredibly simple and easy to construct and very fast. In this build, which was built by Midlands Heritage Builders, the blocks are set 25 mil off the frame, so that once you're plastered, it leaves a 5 mil shadow gap between the frame and the plaster, which architects tend to go mad for. You can also set the frame into the blocks, but still have it on show, as in this build. So if you were thinking of having a feature frame anyway, like an oak or glulam, then I'd really recommend looking at the giant blocks and this way of building. And here's a couple of shots of blocks and a stud frame. Believe it or not, blocks don't have to be square. They're very easy to curve with a nail float, which is, you can see the nail float in the bottom left, which is shown here, are these infill panels. I'm increasingly using blocks as a permanent shuttering for sprayed hempcrete. They're built up usually on the inside of the wall and either cast or sprayed against from the outside. This means the inside of the house is already dry and ready for plastering, whilst maintaining the benefits of monolithic construction that the cast or sprayed hempcrete bring. On the left there, you can just make out the blocks on the inside of the frame and the spray on the outside. So really the three types are very similar and can be used in much the same way. Cast is specialist, but still very simple and accessible for self-builders. Sprayed is easier for contractors to manage due to the much reduced labour required, and comes into its own when projecting it at an existing wall as solid wall insulation. And the blocks have massive advantages in being dry, but are also completely non-specialised and accessible to all. I'm going to look at some construction details now, but it's difficult to do them in depth in the time we have, but we'll look at a few common details. So the first is racking strength or stiffening of the frame. The rule here is to avoid using boards such as plywood or OSB. The boards are generally very impermeable to moisture. They'll cause a condensation risk in an otherwise breathable wall and will generally not let the hempcrete perform as well as it can. Unfortunately, engineers like to design with boards, but if you want an optimally performing building, you'll need to use diagonal bracing as shown here. The engineer I've always used is Gordy Nelson of Paramount SE, who's not ever had a problem designing with diagonal bracing. If you must use a board, and I admit there are cases and times where it makes sense, then try using panel vent, which is pictured in the top right. It's a more, so that's panel vent. It's a more open, vapor open board and less likely to cause a condensation risk. So as moisture travels through the wall, it hits these boards and will slow down. And in the case of plywood, it would just stop. If the board is cold, say towards the outside of the wall, the moisture will then condensate and cause damp. So the rule of thumb would be to have more insulation outside of the board than inside of it, so that it's warm. The easy way to do this is to use hempcrete on the inside. So if you look at this section, you'd have, this doesn't quite show it, but in this bit here in the middle, you'd have your hempcrete, whether it's hemp blocks, cast or sprayed. And you'd have your panel vent board here, just underneath this wood fibre insulation board. So the wood fibre insulation board's got a very good thermal conductivity. 120 mil of it will be equal to probably 160 or more mil of hempcrete. And in that way, the panel vent board won't cause a condensation risk. Sprayed and cast lintels or lintels for sprayed and cast hempcrete are very similar. The stud frame will always have its own structural lintel in place, so you're really just making sure that the load of the hempcrete transfers across the opening or back to the structural lintel. So for small openings, if you look in the top left, you'd build your hempcrete up to either side of the lintel. You'd then place a 2x2 or 50x50 mil batten in the middle of the hempcrete section right the way across and projecting 150 mil into the hempcrete. Then you'd cast this whole section in one go without stopping, and the 2x2 batten then ends up acting like a rebar. For a larger opening, for cast or sprayed, you would screw maybe slightly bigger timber to the structural lintel, and then again cast or spray it in one go, and in this way it transfers the load to the structural lintel, the timber frame lintel, rather than the hempcrete on either side. For small blocks, the load is transferred back to the structural lintel as shown on the right hand side, with stainless steel L brackets at each block joint. So that's very simple. And for the giant blocks around a portal frame, precast hempcrete lintels can be produced, which are reinforced with structural timber as shown in the picture on the bottom left. Openings can be temporarily shuttered or permanently shuttered. Here, temporary shuttering has been used. So once removed, you can see the frame and the hempcrete. And it's hard to see here in this picture, but flick through. This hempcrete here is actually rebaited. So when the window sits in, the hempcrete on the inside covers the window frame by about an inch and reduces cold bridging. In this build, the hempcrete has been permanently shuttered with wood wall board, which is put up before you cast or spray and remains in place. So you can see the wood wall board there. That's the wood wall board in the top left, and you can see it's been put around the openings before hempcreting and where it will remain. This is the benefit of making the hempcreting easier, especially when spraying, and it also reduces cold bridging between the window frame and the timber frame. Oh, sorry, I prefer using wood wall board because it's the same texture and porosity as hempcrete. So when you're plastering or rendering, you can treat it the same as the hempcrete and you don't get cracks that would otherwise be risked by using a dissimilar material or board. These windows I've permanently shuttered with the finished timber surrounds and sprayed up to them. So I left enough space for the plaster to finish flush with the timber window surround. And then a kind of face frame, a bit like an architrave, was fixed onto the front once the plastering had been done. So that was very quick and easy. The boards were put in place before I hempcreted, sprayed against, obviously they were protected, and they're there once you take the protection down. With blocks, no shuttering is required, and you simply plaster onto the reveal created by the blocks. Again, if you want them curved or angled, it's very easily done with a nail float, and the circle on the right was cut out with an alligator saw. The roof junction is much the same with spray, cast and blocks, and the key is to make a robust airtight join. Here you can see the hempcrete coming up to the top of the roof rafters, just there. Then a thin layer of sheep's wool or hemp fibre is sandwiched between the hempcrete and the wood fibre insulation sarking board, which is this board here. So there's another board going to go on here, which is going to sandwich that insulation between the hempcrete and the board, and that will basically take up any gaps that might appear, through slight movement in the frame or shrinkage in the hempcrete. Then the rafters are full filled with blown cellulose insulation, which is blown in under pressure and meets the back of the hempcrete wall, further increasing the air tightness. There are so many ways a plinth can be constructed. So for now, all I'm going to say is that it must keep the hempcrete at least 250 mil off the ground if the hempcrete is to be rendered. It must not allow any cold bridging or water ingress, and foam glass aggregate and foam glass blocks are very useful. So this is the foam glass aggregate here and the foam glass block, which are insulating, can take structural loads, and they don't let moisture through, and they don't wick up moisture. Sprayed, cast and blocks can largely do all the same roles. They can all do walls and roofs. Cast roof on the left there, block roof in the center, and a sprayed roof on the right. They can do floors, although I haven't got a picture of a block floor. There's a sprayed floor on the left and a cast floor on the right. They can do solid wall insulation. So they're sprayed on the left there, straight at an old stone wall. The bottom panel in the middle picture there is cast hempcrete as a solid wall insulation externally. And the detail on the right shows how blocks can be easily built up against a wall as solid wall insulation. And this layer here is a bit of cast hempcrete that you chuck down between the gap if you had a wonky wobbly stone wall. And they can all do infill panels, the cast on the left, the blocks on the right, and courtesy of hemp lime spray, the sprayed infill panels in the middle there. So let's compare them on cost. The easiest way I thought I would do this was to look through my back catalogue of jobs and see what I actually charge my clients. For each, I've noted down my lowest and highest price I've charged for sprayed hemp, cast hemp, and the hemp blocks. This is a supplied and fitted cost and is per cubic metre. So if you want to know it per square metre of wall, you'd have to divide the cost by the thickness of the wall in metres. As I could have guessed, the spray comes out cheapest due mainly to the lower labour cost, followed by blocks and then cast. What was interesting is that the larger the block, the cheaper the price per cubic metre. So the giant blocks were at the lower end, £450 per cubic metre fitted, and the price increases for smaller blocks. This is because it takes the same amount of time, roughly, to lay an 80 mil thick block as it does a 160 mil thick block, but you get twice the hempcrete. It's worth considering, though, that this is what I would charge, and your local builder could install the blocks for a lot less than I would. Also, bear in mind that if you lived far from someone who owned a spray machine, let's say in North Wales, for instance, but close to a local hempcreter, let's say North Wales' very own Hempcrete Cymru, then the cast hempcrete by your local Welsh lad would probably be cheaper than myself travelling from the southeast of England with a spray machine. And quick shout out to my cousin Jasper and his business partner doing great things with www.hempcretecymru.com. So all the types of hempcrete will perform very well It's like comparing a BMW, a Mercedes and an Audi. There's not a lot in it. If you're a self-builder, you're likely to go for cast hempcrete or blocks. If you're paying a contractor, you're likely to go for sprayed or blocks, unless you have a casting contractor nearby. And if you can't afford to wait for any drying time, or you just want to use non-specialist labour, then you'll probably choose blocks. Don't forget, you can mix and match in the same build and combine with hempcrete with other natural materials. So on the subject of other natural materials, I've been asked to say a little bit about mortgages and my experience of self-building and mortgaging a hempcrete house. And there's a certain material that can help with this. I know some people struggle with natural materials and mortgages, but that can sometimes be the way they approach and present their build to the mortgage company, saying things like, hey, I'm building a hemp house. And the mortgage company say, hey, what the hell is that? And they close the door. But in fact, you're not building a hemp house. You're building a structural timber framed house with natural fibre insulation called hempcrete, externally finished with lime render or timber cladding. And then they say, hey, we deal with timber frame buildings, please come in. Of the mortgage companies that lend on timber frame builds, some will state that you can only timber clad a certain percentage of the external facade due to fire risk. Other than that, the lenders say it must adhere to building regulations, be insurable and have a 10-year structural warranty. So really then your main problem is you've got to find a warranty provider and see what their criteria is. But it didn't take me long to realise they're only really interested in the structure and the external weatherproof finishes. The structure must be signed off by an engineer with up-to-date liability insurance, which is not difficult to do. And the weatherproof finish must be guaranteed for at least 10 years, which can be slightly more difficult as at the moment there's no one providing a guarantee for lime render over hempcrete. And my house is partly rendered. So the easiest thing for me to do was to cover my hempcrete house in a tea cozy of warm shell wood fibre board, which is an insulation board by Lime Green Products, which carries the BBA warranty certificate for external use with cladding or with their lime render. So that's what I did. And as you can see in the left picture, I put 120 mil of wood fibre board all around my house. And so as far as the warranty company were concerned, it had a BBA certified exterior, and they weren't really bothered about anything else that I did. And the picture on so I didn't have a problem with the building regs, the warranty, or the insurance, or my mortgage company. I heard very little from all of them. And the picture on the right is my second development I'm doing myself, which I'm working on at the moment, a historic barn, which I'm converting to sell or rent out, where I'm doing the same build up, hempcrete on the inside, sprayed against the wood fibre board, which will then be clad over. So thank you very much for listening. Good luck with your own builds. If you'd like to contact me, my email and Instagram is there. And if you'd like to find more about me and my work, then head to www.thathempcreteguy.com, where you'll find lots of useful videos and downloads. I think I've stopped sharing that.
Thank you so much, Will. That was really brilliant. We're now going to move south of the channel and go to Sonia. Sonia, are you ready?
Yes.
Amazing.
You can hear me? Is okay? Okay. Okay. So first of all, I would like to thank everyone for the invitation for this masterclass. Sorry for my French accent. I hope you will understand everything. We are really happy to share this experience with you tonight. For the introduction, so Le Moelle et Le Moelle is an architecture and landscape office based in Paris and Rennes in Brittany, founded by two brothers, Christophe and Jesse Le Moelle, in 2010. After 8 years, as a founder of my own company, I joined the office as a partner in order to use my experience as a landscape architect. So let's dive directly to the project. Can you see that? No, it's
I can't move to the next.
Ich bin schon dabei. Bist du überhaupt nicht.
Okay. So Croissy-Beaubourg is a suburban commune of Seine-et-Marne. As you can see, this is Paris and this is Croissy-Beaubourg. The characteristic of this typical urban fabric is with a strong dominant residential, as you can see here, all over there. This is a side project and this is the building. So as an echo to a city center, the project is a new multipurpose sports hall located in the center of a set of public facilities. As you can see, here is a school, a gymnasium, and a leisure center here. In addition to this particular context, it's important to clarify one thing, which is not that this project is not the result of an architectural competition, how is done like everyone. In France, we developed a specific thing which is called procédure adaptée, which could be translated as adapted process. The word adapted is here very important since it will illustrate the aim of adapting a project to a budget beyond any architectural consideration. In the way the scheme is presented as a proposal mainly based on the methodology and the capacity of our office to propose a solution which will be able to found the good scale for the municipality. It means, so that's the project, it means that when we started the contract, we had to design the building, find the right implementation in the context, and define all the characteristics of the future buildings. So that was the first images that we showed to the municipality when we just started the project. In response to a constrained budget, it was estimated in the design brief around 650,000 euros. So it's almost 550 British pounds, I would say. The structural principle of the project was guided by the desire to use sustainable and multi-performing materials. So my engineers proposed me to use hemp block during a meeting. We never heard about hemp blocks before. Of course, I had seen operation done with a concrete hemp case in place, but I was not aware of this type of hemp-made product. It described me all the benefits to use that specific types of materials for our project, like versatility, thermal, acoustic, structural, and fire resistance performance. And also, that was a good point for us. The hemp grown in France, the fiber are assembled within 500 kilometers from the project site. So the hemp blocks participate in valuing short-term sector. So here you can see the building side bird view that we picking up. So Pierre Chevet Sports Hall is the first public equipment built with hemp blocks in France. This constructive process has been possible to respond to requirements. On the one hand, it participates in engaging the actors of the building sector toward an ecological transition. The project provided an opportunity to a mentor company to these techniques. On the other hand, the constructive techniques does not require specific certification or qualification. For example, on a small-scale project such as Pierre Chevet, small local businesses were not excluded and could therefore respond to the call for tenders. Similar to our traditional cinder blocks, these are products based on chenevotte, so this is a French word. I don't know how to say it in English. It comes from the inner part of the stem, also called straw, which is then cut mechanically to obtain hemp shaving. This is an agricultural materials, until then without outlets. This base is made very compact thanks to a quick natural cement binder developed by Vica, a French cement group based in my natal region, Rhône-Alpes. So this is the picture of the product that we use. That one is from Vica marketing picture. And on the other hand, this is from the building side. So measuring 60 by 30 by 30 centimeters. The weight is almost 18 kilos. and it's easy to cut. The blocks are not glue, as you can see. They are just nested. The funny fact is that the guy who was working on this building site was a former stone cutter, and he found the same technique that he was using in stereotomy. So this is, I will explain a little bit more about the structure of the building, how it was to free as much spaces as possible for this really small project. So on the axonometry, reveals a structural principle. There is semi-porticos and wooden turns supporting on the hemp block wall on a reinforced concrete post beam frame. The peripheric walls form a U from 3 meters high and rising up to 5 meters from the central wall. There is 42 cube meter, of walls, and everything was mounted in almost 10 days. The lower part of the program, so here, there is all the changing room, all storage and technical rooms. And here is the main large space, is the dancing room. These have wooden porticos, as you can see here. I would show you. This is more images of the building site. Like, as you can see, the different people who's working on some details here. This is the details from the inside of the building. And here is when we started to build the timber structure, who was attached to the hemp block wall over there. And this is inside the main room, and this is the hemp block highest wall inside, and the timber structure over there. So because we wanted to offer durability to the facade, we decided to use full height fiber cement panel, keeping the standard format, as you can see here. And that was the starting point to do the patterns layout of all the facade. But how to attach a 10 millimeters thicker and heavy cladding panels of almost 18 kilos per square meters to a hemp wall? Throughout the project, we were able to discuss with the head of VICA, the manufacturer, who has developed the technical requirements for hemp blocks. I must say that this project was a collective work between each partner, our office, the engineers, the manufacturer, the people who's working on the building site, like Pierre says from VICA, he intervened on that question with the facade, as you can see here, because it was the first time that a facade panel was fixed with this kind of walls. We had to review the hook system, as it was impossible to create intermediate points. In all this facade, we have to put the facade panel from the lowest part to the highest part. The structure therefore starts from the lower point on the ground, from the cellular here, cellular block. Then we can to fix the holder on the large omega over here in the head of the pool filled with concrete, which offer the panels a resistance to put out and wind. The waterproofing was made by the simpler primer coat applied to the hemp blocks prior to the panel installation. So that's the final result here. Here you can see is a small section, the hemp blocks here, the primary coat on the outside, the omega metal profile, and here is the front panel. So we started from that small concrete part block here and go onto the top like 3 meters higher. And this is a detail from the inside, as you can see. window coating here. So it helps us to reduce the number of different materials used. Like here is the traditional concrete blocks, where you have the concrete block, the insulation, and the finishing inside, and you have the facade over there. And that could almost be the hemp block section of our project. You just have to add the layer of the paneled facade here. So as I said, it helps us to reduce the number of different materials used on that project. Due to its multiple quality, the hemp blocks make it possible not to use dumping and to reduce the thickness of the wall to the essentials, so that we could give much spaces to the program as we can expect it on the traditional concrete block building. So how you can see, this is the inner facade surfaces here. Were treated with hemp coating in the lower part. Free of insulation and gypsum board, hemp blocks also offer a sound absorption property. It's almost 43 dBs. That's why in the highest part of the dancing room, the blocks are left visible in order to preserve the aquatic qualities of the hemp block. We have estimated an additional cost of about 30 to 40% on the supplied posted price, which out of the total amount of the operation represent 2% of the construction global cost. This is the main room when we finished the building. So the main challenge was to convince the client that hemp is a good alternative to the concrete, because since the beginning, the municipality had no specific requirement about the employment of bio-sourced product. They were not implicated at the time of what was being prescribed and stopped at the word cinder block. We had to explain that these materials allow sustainable saving in long-term approach. It can represent, according to some studies, up to 70% of head saving in the case of a building high thermal performance. According to the modeling done by our engineers, primary energy consumption is estimated at 167 kilowatt per square meters per year, with the gas consumption reduced to 42.7 kilowatts. This really modest project was commissioned by the city without performances requirement label or certification. We carried to use hemp without any obligation. The figures provided today are therefore not the result of a regulatory requirement, but just show how individual desire to go further with the support to all of our partners. As an adapted process, we tried to find a solution that could prove to the client the ambition of a project is led by its scale or budget. In this case of this project, we wanted to show that even in a very small city, sustainability could always be used as a flag to project. Thank you.
Amazing. Thank you, Sonia. That was really, really interesting. In a last minute change in the running order, Paloma, we're going to hear from you next. So thank you so much, Sonia. And Paloma, I'll hand over to you.
Unmute first and then share. 1 second. Hello, I'm Paloma Gormley. I'm here, I guess, with two hats on. So one hat is my practice architecture hat, which is the practice that I've been running with Ettistrake for maybe 12 years now. And then the other hat is Material Cultures, which is a kind of newer research organisation, which I run with George Masood and Sama Islam. Both organisations quite preoccupied with hemp. So I'm going to be talking about a couple of case studies, so a few buildings that kind of deal with hemp in two different approaches, and then about the work that we're doing with Material Cultures to kind of scale up the use of hemp and the kind of regional approaches to construction. Also to say, I've quite recently become a mother, so I'm kind of high on endorphins but low on sleep, so that might affect my brain capacity today. So the first project I'm going to be talking about is we call the Weaver Studio, and it's in South London. And it's a studio on the ground floor and then these two apartments above. And it's a project that kind of developed around this quite solid, maybe oversized timber frame made of locally sourced Douglas fir. And the constraints of the project, which meant that we had to build it effectively overhand using the structural timber frame itself as the scaffolding, because there wasn't any space around the site to erect one. And so we were kind of looking at materials that would work with the constraints of the project, and also the desire to kind of really show off this structural frame. And in the end, kind of running through our short list of materials, hemp just really kept on ending up at the top for many, many reasons. And not least its kind of sustainable or ecological credentials. So we built the building almost like a giant barn. The structure went up, the floors went in, and then it was clad kind of on the, I guess, the exterior cladding was put in alongside the wood wall board, which you can see in this image. So we have this big structural frame, and then wood wool here, and then battens which support the exterior cladding. And the wood wool, as described by Will, and as consulted on by Will, I think he came up with this detail for this project. The wood wool provides a permanent shuttering in the building, so it just kind of goes on and stays there, and is the substrate for the hempcrete that came later. So this is us casting the hempcrete, and very, very lo-fi, just a few hired cement mixers and a lot of labour. So we kind of called in everyone that we knew almost to come and help install the hemp. And you can see the hemp shiv in the foreground here. So it's the kind of woody core of the plant. Basically, it is very good at storing air. It's got a kind of spongy texture, so it kind of holds its structure even when it's mixed with the lime. And then here, I think you can see it in the foreground, that's the lime binder. They both go in together into a cement mixer, and then you get it in the shuttering. So we were casting in situ, as Will described, and kind of building up in layers that form these kind of strata that become quite a kind of beautiful kind of visual record of this process of kind of tamping in and building up the hempcrete. This is the binder before it's fully cured. So there's this kind of stage when it all went quite this kind of deep murky green, which we actually quite liked. But when it dried, it dries quite a lot lighter. This is the ground floor of the building, so the workshop. And there were elements where we wanted to kind of reveal the full depth of the structure. So we kind of had a different insulated approach in some areas of the building, but the majority of it was just kind of cast in situ hemp right up to the face of the structure. So the shuttering in this case was screwed directly onto the front of the frame, which means it ended up with this kind of flush hempcrete. And I think from this project and a few other projects that we'd done prior to it, began in practice architecture to develop a few kind of principles. So this idea that's already been touched on of kind of monolithic construction. So the idea of eschewing this very layered construction, which we've become very used to, and I think which is developed in the context of a kind of petrochemical based material economy, and also the kind of idea that moisture shouldn't kind of move across a building, but should be kept outside a building fabric on either side, and then kind of libelous warranty based cultures as well. We've ended up with this very kind of fragmented, layered building technology. So one of the really exciting things about hempcrete is that it simplifies that right back, and you can have kind of 1, 2, 3 materials as your entire wall build up, which feels really exciting, and kind of like it makes also kind of construction much more accessible again, less technocratic. The other thing is using biogenic materials, the materials that have been grown essentially, and that sequester carbon and lock it away as they grow. Breathing construction, so allowing moisture to kind of move across the kind of fabric of a building, the wall of a building, which has so many benefits. So kind of modulating the amount of moisture internally, reducing mold, etc. And then also this idea of resilience, so designing for passive kind of fire resistance, and that means for timber, just like oversizing timber rather than using intermittent coatings. And then with hempcrete, it's kind of inherently fire resistant just because of the lime content. So it gives you very, a lot of things in terms of performance. Another principle for us is the kind of compostability. So the end of a material's kind of life, the material or a building's life cycle, that the materials used in that building, or at least the gross majority of them, can be essentially kind of mulched and composted and returned to the ground and into kind of biogenic life cycles. But I think something that we began to feel in relation to these kind of one-off bespoke projects was that whilst they can be really useful in terms of kind of experimentation and discovery and learning, and that if we want these kind of technologies and ideas to spread them, we need to also look at how they can scale and be kind of competitive with the existing material cultures. And in response to that, we established this organization, which is kind of research but also design organization, looking at how low embodied carbon materials can kind of intersect with the latest construction technology in kind of highly efficient processes. So Material Cultures is part kind of research center, part kind of laboratory. We build buildings at different scales to test things out, and we also work in a kind of educational capacity as well. So Flat House was the first project that kind of began to manifest some of these ideas, and was kind of part practice architecture, part the birth of Material Cultures, and was it was a house on a farm called Margent Farm in Cambridgeshire, for which we grew all of the hemp used in its construction. So the kind of first process almost in building the house was to grow the materials. So we planted a crop at the beginning of the growing season and harvested it kind of 3 months later. And from there it was processed. So the shiv was used as to form hempcrete, which went into these panels. We devised a very simple structural system based around the 8x4 sheet. So just a kind of regular dimension. I think my new little friend is coming upstairs, so she might get even louder. And then that hempcrete was cast into these panels. And you can see they're kind of coded, so essentially we could get them into place quite quickly on site. And we explored different finishes, so how you could essentially seal the hempcrete, whether that be with a lime plaster or a wash of paint, and whether that process would happen before or after its kind of assembly on site. This is the assembly on site, and you can see this, the conditions weren't great, but also that it's a very simple and in a way quite a crude process. So these panels that kind of had the conduit pre-installed, that was probably the most high-tech bit about the project, and then some quite basic, if oversized, tools with which to get things into place. So we basically used a crane, and over 2 days put all of the panels up, and had the kind of the base fabric of the house very quickly. So it was a real shift, I think, from the project that I just showed you, in that, yeah, the speed on site was just extraordinary. And in terms of a kind of rationalization for mass construction, what off-site construction means is that you can, all of those drying processes happen somewhere else, and potentially in an assisted manner. So you can essentially dry with cold air or warm air before they even arrive on site, which means that the construction window becomes year-round rather than in situ hemp, which you can't do in the coldest months of the year. This just kind of gives you a sense of the form, but also that we were doing it under Part Q permitted development, which meant that the kind of volume of the building essentially followed the existing shed. And following on from what Will was describing, working in conjunction with other materials, this is wood fibre insulation. It could equally as well be in hemp fibre insulation, which is now being made in Scotland by Indie Nature. And we used it in the ceiling and the floor, and also as a kind of outer jacket out on the outside of the building. And in parallel to this project, we were also working with Margent Farm to develop a cladding product which used the other part of the plant. So from the stalk of the hemp plant, you have the shiv and you have fibre. So the fibre of the plant was used, combined with a sugar-based resin and compressed into these panels, which then clad the building. It's changed a lot now, because you kind of have to see hemp fibre as a natural product, and it behaves almost like timber does, and it kind of silvers and lightens over time with UV exposure. And it's being in the process of being kind of launched as a kind of product that should be available. And we're kind of fast learning through that process the difficulties and the hurdles that there are to overcome in bringing something new to market, seemingly, particularly when it's a kind of natural or bio-based product. It seems like they almost make it even harder for you. So that's, I think, one of the things that we're also kind of looking to explore and enable. This image maybe just shows a bit about the kind of thermal kind of intentions of the building. So there's this big south-facing glass house, and then the hemp wall here. So the idea is that there's kind of solar gains are banked in that wall and radiated back into the house. So it's another kind of layer to the passive thermal strategy, as well as the thermal mass of the hempcrete, giving that additional kind of heat and thermal performance. This is a plan. So there's 2 small bedrooms and a kind of 1.5 height living space. And then going into the house, we decided to leave the frame exposed, partly well, because we enjoyed that expression of the materials, but also for this project, it felt really important that everything was really, really legible, because it's kind of a demonstrator and as much as anything about kind of showing how hemp works and can be used. We use kind of timber in as raw a condition as possible, wherever possible. So we try and kind of shy away from glulam and plywoods, whilst they still use a lot of kind of polyurethane glues, etc. Make them non-breathable and not particularly sustainable. And then just kind of enjoying the kind of atmospheric and acoustic qualities of the hemp that really create this very close, warm acoustic quality that's quite unusual. I think we're used to spending lots of time in spaces that are quite hard acoustically. And then complementing the hempcrete with other materials like the wood wallboard, which is kind of shredded timber, and unfortunately has quite a high cement content, but is still a kind of very useful material in your armory when you're looking at breathing construction. The house was calculated to have -5 tons of carbon, which, if you compare it to a conventional house which has produces 50 tons, is not bad, but can still be improved on, I think, because this house had concrete foundations and other kind of high carbon elements that could still be swapped out, and that's something that we're looking at doing in future buildings. And then it performed extremely well in its kind of EPC, the kind of standard performance data that doesn't measure embodied carbon. We're now looking at regional scaling with a number of projects. So this is kind of material cultures work. This was a report that we did in collaboration with Arup, which looked at Yorkshire and the Northeast in particular, and we focused in on hemp. Yorkshire is the largest grower of hemp currently in the country. And in terms of insulation, we were focusing on hempcrete and hemp fibre bats. So that's hempcrete with the hemp herds, and the fibre bats with the fibre that comes from the stalk. And then looking at what the implication of a shift to bio-based construction might mean in terms of kind of landscape and in terms of agriculture. So in order to build the 30,000 homes that the region requires, if all of those were built with a hemp fibre bat, you would require 8.6% of the total land area to be growing hemp, which seems like a lot, but that's only considering the fibre as a kind of output of that land area. So you'd also have the oil, the shiv, etc. But it's also kind of interesting insight into what would be required were we to kind of actually make this transition. And as we mentioned before, hempcrete has the ability to, not hempcrete, hemp as a plant has the ability to be integrated into other growing cycles as a kind of crop rotation, because it helps rehabilitate the soils. There's going to need to be other changes, I think, predominantly in terms of regulation, in order to actually drive be a kind of kickstarter or drive the market. And then there's quite a lot of kind of infrastructural development that's going to be required in order to be able to process the amount of hemp that we would need. And then just a comparative study of what something like, for example, PIR insulation looks like as a kind of life cycle analysis relative to hemp and hemp fibre. So clearly the ability to both reuse, reprocess, and then compost at the end of life, creating a kind of circular material rather than a non-circular one. We're working on a number of large-scale kind of housing projects, looking at applying some of the principles from flat house, but at a larger scale, and across multiple sites and blocks. So this is just some images of a project that we're developing in the south of England, and then a kind of overview of how that might look at a kind of city/block scale. But exactly the same principles as a kind of in flat house, but kind of scaling up but really tying into regional producers in terms of timber, but also sourcing other materials such as chalk to go into the project. And a final little bit about material cultures, which is how important kind of education is in the work that we do, both for kind of generating kind of experimental ideas and research, but also in skilling up the next generation of kind of architectural practitioners to be part of this conversation and to be kind of fully informed and have all the tools that they need going out into the world as architects. So this is just a few projects that we've done with them, which kind of often one-to-one scale, kind of testing, making through doing, understanding architecture by having a real relationship to materials and construction. I'm going to finish there. I've probably run over, and I think my baby needs me. But thanks, everyone.
Thank you so much, Paloma, and thank you particularly for your commitment to keeping going. I hope your little one is okay. But yeah, thank you so much for your time. And just to echo some of the comments in the chat, some really, really beautiful projects. So yeah, that was a wonderful, wonderful talk. We're now going to hand over to Alex, who's our final speaker for tonight. And Alex is another sort of real key voice for the hemp building industry in the UK. Alex, over to you.
Great stuff. So hopefully everybody can see that.
Yeah.
In full screen mode. Good. This is the nail biting bit to see whether I've reduced the PDF size enough for it to move on quickly and keep up with me. So thanks first of all to ACAN for putting on this event, and thanks for inviting me to speak. Been really impressed with the work that ACAN's been doing over the past couple of years. And so I'm here today, really, I've been asked to talk about Hemp Performance. Okay, so this is just to put us in context. So UK, oh, I need to apologise. UK Hempcrete is a small company in the UK, for those of you who are joining from abroad. And we specialise in the structural envelopes of buildings, from bio-based, mostly waste biofibres, carbon sequestering materials, often recycled materials. And for sort of overview of what we do, we supply materials, we have consultancy services here and abroad, and we do a lot of contractor training and working with architects, developers to help them to integrate hempcrete into their projects. And we have a growing in-house design practice, which specialises in design consultancy, mostly around the use of hempcrete and the detailing of hempcrete in buildings and specifying it in a robust way. So, as I said, today I've been asked to talk to you about the performance characteristics of hempcrete as a material. And also, I think I was asked to speak a little bit about contractor training. So, with an eye on the time, not be a deep dive really, because of the time that we've got to do the presentation. So I'll hopefully try and be clear. Won't be able to go into huge amounts of detail, but if you have any questions afterwards, do get in touch. So this is what we're going to be looking at hopefully over the next sort of 20 minutes. I'm going to start with fire because it's a really key one in the UK at the moment, and it's sort of the first question everybody asks us. This is, as the other speakers have shown, there's a really good range of different hempcrete materials on the market. This is happens to be the block system that we supply, and if you look down to the bottom of that table, I just wanted to pull out the fire testing on that block system. So reaction to fire, obviously without the lime render on it, it gets a B class reaction to fire rating, and that's because it's got a bioaggregate hemp. So after a while, subjected to flames, it will char, but it doesn't ignite, as the other speakers are saying, because it's wrapped in that lime binder. And it also doesn't transmit heat very quickly through the material, so the heat doesn't spread through the building element that is on fire. And also, because there are no chemical treatments to hempcrete as a material, there are no sort of noxious off-gassing when it is exposed to flames. With a render, lime render, obviously it gets an A2 reaction to fire rating, and then in this particular manufacturer has tested resistance to fire at a 12 centimeter, 120 mil, and a 200 mil block, and they get a fire rating of 60 and 120 minutes, 2 hours. Respectively. I also we're going to come back to this a little bit later, but I just want to draw your attention. If we look at the 20 centimeter, the 200 mil block here, I just want to draw your attention because I want to refer to it later on, to this row here, which is the phase shift, which is the time that it takes energy as heat to pass through the envelope. So, and this is in hours, okay? So I just want you to remember that the 200 mil of hempcrete is, well, in this case, 13 hours, but typically 12 to 13 hours, okay? So we're going to demonstrate some of the performance of hempcrete with hopefully some nice pictures of some of our projects. And I thought we'd start with this whole envelope hempcrete house. As Will was saying earlier, hempcrete can be used in all elements of the building envelope. So it's possible to build a house that has a hempcrete floor, walls, and hempcrete in the roof insulation buildup. And you get this kind of complete monolithic envelope made from one homogeneous, well, arguably one piece of material that's wrapping all the way around the structure of the building and complemented with other materials along the way, usually some other natural insulations and lime renders and clay plasters, lime plasters. So we're going to take a walk around this house. This is a new build house for an architect who it's her own house. She currently lives in the farmhouse there, and she's moving into this house. And this is it when we'd built the frame, done the hempcrete, done the roof insulation, which as I say is also hempcrete. We'd done the hempcrete slab in the floor, but the floor wasn't finished. And in fact, the internal finishes have been left because the architect client is going to self-finish, in this case, the inside of the building. So this was a visit that I did sort of 8:30 on a cold February morning up in the Highlands. And the condensation that you can see on the windows is actually on the outside of the windows. So inside the house is perfectly dry because, as we know, hempcrete has this ability to absorb and release moisture. But in fact, the moisture in the external air is condensing on the windows in this sort of unoccupied, unheated, unfinished building because it's retaining warmth. Okay, so you can see from this photo that the sort of snow-capped mountains in the background. This is in Perthshire in the Highlands. Early on in February, the external temperature is 2 degrees, which is sort of balmy for that location at that time of year. And the internal temperature is 16.5 degrees with no heating at all, other than obviously the passive solar gain from these large south-facing windows. Even further north, the house we did on Orkney mainland. This time when I visited, it's late October. There's no heating system installed in the house. It's unoccupied. It's got wood fibre insulation in the roof. It's got hempcrete walls. It's got again an insulated floor, but this time the foam glass and with a lime screed. And to be fair, to full disclosure, there is a one painter and decorator in there painting the walls, so he's probably kicking out a bit of heat. But again, the house is staying 16 to 18 degrees, quotes whatever the weather, and believe me, on Orkney mainland, they see all kinds of weather. So why is it doing that then? So if we look at the sort of typical hempcrete performance, and there are slight variations with different hempcrete materials, but they're broadly very similar. This again is from taken from a hempcrete block performance table, different block system. And again, so you've got the thickness in centimeters of the different blocks along the top of the table, and then you've got the density, which obviously remains constant. But the first thing you notice that for an insulating material, this density of 330 kilograms per cubic meter is way in advance of a typical sort of lightweight insulation like a sheep's wool, etc., which might be around 25 kilograms per cubic meter. And the reason for that, of course, is that the lime in the binder makes hempcrete a sort of material with moderate density. So as the density increases, the insulation value decreases, or in other words, the thermal conductivity of the material increases, so heat's passing through it faster than it would through a lightweight insulation. Okay, so why is that a good thing? Well, the reason that hempcrete is denser and less insulating is because it has this moderate density, which gives it this specific heat capacity, 1870 joules per kilogram Kelvin, which is describing the material's ability to store heat in the fabric of the material, which is really quite unusual in an insulating material. There are some others that do it. Aerated concrete blocks being one, but they lack one of hempcrete's other key performance characteristics, which is a very low move value. In other words, a very low resistance to moisture vapor. So it's very vapor open. Okay. Now, as a result of that high thermal conductivity, or relatively high compared to other insulating materials, you can see, looking at the U values for the different thicknesses of blocks, that we actually have to meet sort of current UK building regs, which are around 0.18 ideally in new build walls. We actually have to create hempcrete walls that are quite thick to achieve that value. But with hempcrete, the performance of the material is due to much more than the U value. And for that reason, hempcrete massively outperforms what would be expected from its insulation value on site. Okay, and that's because of the material's ability to store heat in the material. So insulation being a layer of trapped air, which obviously hempcrete does have air trapped in it, that's the usual way of keeping heat in a building. But with hempcrete, as well as trapping air and as a barrier to heat transfer through the material, it's also storing some of that heat in the fabric of the material. And that's what gives it this unusually long phase shift. So again, you can see that 200 mil of hempcrete has phase shift of around 12.5 hours. Okay, so why is that? Back in 2012 by Mike Lawrence and co at the University of Bath, looked at an experimental hempcrete building with 200 mil of hempcrete cast around a stud frame, and there was obviously a comparison with an identical building made from PIR. And they heated the building for a little while, and then they stopped heating it, and they monitored what happened in both buildings. And in the hempcrete building, the external day-night temperature was going up and down with day and night, as you would expect, but the internal temperature was staying relatively stable. And that's because that thickness of hempcrete has a 12-13 hour phase shift. So the time that it's taking heat to pass through the envelope of the building is roughly the same as the diurnal temperature changes that are happening outside. And that's why you get that sort of steady, pulled out, almost static temperature in hempcrete buildings, whatever the weather's doing outside. And that's what we're seeing in those buildings when we ask clients, how's it performing? They say, well, we're not heating it yet. It's sort of 16, 18 degrees. And this is a low-tech construction method doing something that seems quite high-tech or seems to be very high performance. So as others have said, it's really simple. It's not rocket science. In the case of this sequence, we've got an internal hempcrete block skin tied back to a timber frame. That internal skin gets built all the way up and is then used as a permanent formwork. In this case, there's a reason I'm showing you this, is there's a kind of arched roof structure internally and a mansard roof externally, because the client's brief was an upturned boat. So she got an internal upturned boat. And so because this is, again, it's hempcrete over the roof as part of the roof insulation, what we've used there is a reed board, permanent shuttering to stay in place, and the hempcrete gets cast up over that. Oh, weird slide transition. Wasn't expecting that. And then once the hempcrete is cast and dried out, then the reed boards get lime plastered, but they stay in place in the building. And so that's the building with the external layer of cast hempcrete to cover the timber frame and give the benefits of that sort of monolithic external, homogeneous external material that wraps around and resolves any thermal bridging. That's the building rendered. And again, lo and behold, it's maintaining 16 to 18 degrees in late October without any heating. Now, another key part of buildings performance, and especially relating to the insulation element, and this is probably arguably less critical in hempcrete buildings than it would be in a lightweight insulation building, is air tightness. And that's because if you have an insulation layer, if it isn't airtight, then air will be leaking out of it, which will compromise your trapped air barrier to keep the heat in your building. So I love this example. This is one of the companies in America who's kind of sprung up to sort of push forward hempcrete. This is Hempstone, based in Western Massachusetts. And I love their example. This is their first house that they built with the client last year, if I'm remembering correctly. So these last couple of years seem to have all rolled into one, don't they? But what Hempstone did, which I really liked, was they did a blower door test at different stages in the build. So with the hempcrete walls only installed, well, weight insulation that was used in the top of the gable and the roof, they did a blower door test and got 23.8 air changes per hour at 50 pascals. They then applied the exterior line render and did the blower door test again, and it dramatically dropped, nearly by, I don't know, whatever that is, 3,000% or something, to 3.02 air changes per hour. But at this point, they still hadn't applied any air tightness measures to the lightweight insulation in the roof structure and taken any attention to sort of ceiling penetrations, because this is obviously a typical American timber frame post and beam house. So when they'd completed that air tightness, those air tightness measures, they got that down to 2 air changes per hour, which is pretty good. What can we do to model building performance? Will be more recognizable to people in the UK, but here we have a procedure for modeling how buildings are going to perform thermally, which needs to be passed for new build housing in the UK. So you can see when we actually model hempcrete junction details, this thermal bridging value here which gives you your kind of calc for the detail. So this is the amount that any thermal bridging in the junction of the envelope sort of is kind of corrupting, if you like, the U value. And that is the crucial figure that you need to plug into your SAP calculation. And obviously that's different. One of the things about hempcrete is it's such a flexible material that the details are kind of almost endless in their, you know, in their, not complexity because they're quite simple, but in the number of different details you can envisage with hempcrete. So you can see there that the tested value is kind of halfway between the sort of default value, which is the backstop if you can't provide a value in the SAP, and the approved value, which is the kind of tick off you go value. Yes, as I say, this is different for every detail, but generally hempcrete, because of the way that it wraps around the structure and eliminates thermal bridging, performs really well. In this case, for this plinth detail, it actually came out that it was better than the approved value. So that's quite nice, and that happens. Vapor openness is a key part of hempcrete's performance, as I drew your attention to in the table at the beginning. Hempcrete as a material is highly vapor open. That's to do with the vapor openness of the finishes. So lime or clay plasters are very open, as are lime renders, and typically hempcrete's used with a range of materials that are natural materials, stone, clay, timber, and all of those materials have really good, well, in the case of stone, depends which stone, but they have a degree of vapor openness. I thought I'd sort of focus on this, which is hempcrete used as an internal solid wall insulation in an old stone barn up in West Yorkshire. And the vapor openness is generally a good thing. It stops water getting trapped in building fabrics, which is good for the longevity of the building. It has some health and well-being implications for building occupants as well. So again, here in this old mill building in Derbyshire, when you're doing internal solid wall insulation with a vapor open material, you need to consider the risk of interstitial condensation. And there's a kind of convention that really, when you're doing internal solid wall insulation, depending on the original masonry wall and the exposure of the building, but you tend to aim for nothing lower than 0.3, because the risk is that you're making the original masonry too cold and increasing the risk of condensation as it passes out of the warm vapor open insulation, but you know, interstitial condensation build up at that point on the interior of the stone wall. So all of the details that we do are kind of checked for based on the climate data in as close to the location as we can find a weather station, to check that there isn't any risk of throughout the whole of the year moisture building up and potentially causing a problem. Although of course hempcrete, compared to other biomaterials, is relatively well protected from that because of the lime binder. So moisture buffering, really key part of hempcrete's performance. It's really good for building occupants, because what happens is the hempcrete wall passively absorbs moisture through the lime plaster. It condenses in the pores of the hemp shiv, that's the aggregate in the material, when the building is humid. And then when relative humidity drops, it releases that moisture out again into the room. So it's passively regulating moisture to a level between sort of about 40 and 60% relative humidity, which is really good for health of those who are living in the building. So I love this bit of research. This is Eshra Latif and co at Bath, who did a bit of research where they got blocks of hempcrete and they applied different things to the surface to see whether they would affect the overall moisture buffering performance of the hempcrete. So I'm presenting this fairly quickly, but I've put the reference so you can go and look it up. So they had 12, I think, 10 different assemblies And what happened was the first assembly was just hempcrete, hemp lime. The second one was hemp lime plus lime plaster. And both of those, you can see, perform in the excellent band for moisture buffering potential, as compared to all building materials and how well they buffer moisture. When you start applying stuff to the surface of the hempcrete, it significantly impacts it, like at least making it at least half as good as the original base case of just hempcrete. Lime plaster affects it a little bit, but basically those two are really the key detail if you want to make use of hempcrete's ability to regulate internal humidity. I was a little bit disappointed. So some of these will be familiar to people, and you can go off and look at the research. So this is wood wall board, which I think Will and Paloma probably both showed in their presentations. And there's different wood wall board cases. So this is wood wall board plus air plus plasterboard, which would be a service void over wood wall board, so it's just a bit of a shame because the most common use of it in hempcrete buildings in the UK is wood wall board plus lime plaster. And they didn't try that. They had various wood wall boards. This is wood wall board plus breather membrane plus service void, gypsum plasterboard and plaster. So basically they kind of tested loads of different things that we don't actually use, which wasn't very helpful. But the main story the main take home, as they say, is that if you put anything on hempcrete other than lime plaster, and I imagine clay plaster would be very similar, if not slightly better than the lime plaster, then you are significantly impairing its ability to buffer moisture inside the building, although it will probably still be in the good range compared to all construction materials. Health and well-being. This is this example cropped up last week. This is this is a house I've been involved with for a long time. It was built by some self-builders called Lloyd and Caroline over the last few years, just effectively just down the road from our office, about an hour away. And they've done a lovely job. We came and we supplied the materials, we consulted, we did a training session for them, and we stepped in to help them with the hempcrete and the timber framing, and we only recently really rendered it. So that they have been living in the house. We rendered it, I think, in sort of August, September this year, but they've been living there. This is their third winter. And Caroline told me that before they moved into this house, and Caroline's severely asthmatic, and she would typically be hospitalized at least once a winter, was how she described it to me, and that she used 2 inhalers a week, typically, and has done for years, wherever they were living. And within weeks of moving into their new house, she hardly uses an inhaler at all. So that's really dramatic. And you can just, I think they've done a lovely job with the design, which was done by a member of their family. And it's just a really lovely, healthy place for them to live and bring up their children. Ooh, contractor training. We must be getting near the end. So this is a building. We didn't build this building, but we supplied the materials. So this is hempcrete block here with a steel frame structure, obviously, with a steel cladding system and wood fibre insulation, and then natural timber cladding, obviously. This is William's Den up in the East Riding of Yorkshire. And as other speakers were making the point that if you're supplying hempcrete blocks, you don't really need contractor training, because anybody who can lay blocks can lay hempcrete blocks. So during my site visit, the only thing I pointed out to them was that they didn't really need to use a petrol disc saw to cut them, and pointed out that an old hand saw, or as Will says, an alligator saw will do just as well. Here's some contractors being trained in the cast method on one of our sites, and that is, I think, as other people have said, something that requires more specialist training. So you either kind of train the people to do the cast on site, and it isn't rocket science, but there's a few things that you need to know about how the material differs from conventional construction materials, or you change the material and supply blocks so that they don't need any training. This is the inside of Native Architects' new, not new anymore, but new in the last few years, office just outside York. And this is some cast hempcrete, which I trained their staff to do their own hempcrete in their conversion of an old granary building. So you see, it's so easy, you can teach architects to do it. And that's the end of my presentation. If anybody's got any questions, I feel that I may not have left that much time for questions in this session, but you know where we are, and please do get in touch.
Thank you so much, Alex. That was brilliant. And I love that little dig at the end. That sounds like a dream Christmas party, learning how to cast your own hemp. We've still got over 100 people in the room. So with everyone's blessing, I think, you know, we've had so many fantastic questions come through in the chat. It'd be really nice just to give ourselves a bit of space to overrun. As always, you know, thank you so much to all of our speakers. You know how difficult it is to squeeze that amount of experience and intelligence into the tiny, tiny slots that we give you. And you all did a brilliant job, and we do not begrudge you one moment for going a little bit over, because it's always so fascinating to hear everything that everyone's got to say and share. And, you know, we started a little bit late anyway, so it's our fault really in the first place. Will has been doing a fantastic job of smashing so many of the questions that have landed in the chat as we've been going, but we just want to pull out a few just to have a bit of a chance for discussion now. We have sadly lost Paloma to childcare, as I'm sure people guessed, but we will share the questions for her with her, and hopefully email that out as part of the Eventbrite email out afterwards, so that we don't miss out on any of those insights. But just to kick off, I have the space, so I'm going to take it. But one thing that I've been really interested in reading into recently is the impact of lime on internal air quality, and how it sort of, you know, continues to absorb CO2 once it's been laid, and can actually have a huge power to clean internal air quality. And I would imagine that with the sort of lime content of hemp block and hempcrete, it must do a very, very similar job. Are any of you guys aware of those kinds of internal air quality benefits? Alex, jump straight in.
Well, I just, not the air quality stuff, but I just spotted a myth. Hempcrete doesn't necessarily continue to absorb. Well, it's a bit of a kind of a myth, because basically when you burn limestone to make lime, it gives off carbon dioxide, and in the process of it setting, lime, or any lime but hempcrete binder, will reabsorb some of that given off carbon. So then there's a bit of a myth going around that if you build a building with hempcrete, it just continues absorbing carbon indefinitely. So that was just my bit of myth busting for the evening, and Will can answer the one about.
I don't know about like any actual tests about the indoor air quality, but after living in a hempcrete house for 4 or 5 years now, I get, when people come round, they always comment. I have people coming around to look at the place all the time, and I always get comments like, oh, it feels so nice, or the air's so fresh, or it's warm, but it's not warm in one place, it's warm everywhere. And then I had a guy who is building a hemp house locally, who is hyperallergic, whatever the word is, hypersensitive to you know, things like new carpets and VOCs and those type of things. And he's just a normal guy. He was a builder, a developer, and he became hypersensitive to these materials. And he showed me a picture of the last time he moved new carpets into a house, and his face was just swollen. You couldn't see his eyes, and it was like that for a week. And he says when he goes into shops and things, his eyes start watering. And so he was coming to my house, and I thought, oh my God, what if his eyes water? I'm going to have failed. But he came round and he said, you know, he doesn't get that in here, and he's a good barometer for whether you've got good indoor air quality. So I haven't seen any tests, scientific tests, but I know from experience of living in a house like this and what people say when they come round, that it is a very nice environment. But one thing I would say is, if you're using hempcrete like that for moisture buffering and for the amount of lime that's in there to be, do all those good things, then I've switched to now using very textured clay finishes, because if you're wanting the moisture, especially moisture, to access the hempcrete, and then you put a very smooth lime finish over it, although lime is breathable, you're creating this, when you're troweling it, you're creating this layer of lime on the surface that is actually more impermeable than it needs to be. And by doing textured plasters, you're increasing the surface area for moisture to go through, or for things to be absorbed through. And then by using a fibre, you're creating little pathways in your plaster. And then if you use clay rather than lime, you're making an even more vapor permeable plaster for things to access your hempcrete.
Thank you. I mean, I think that, that consideration of the health of the people who are actually building our structures in the UK is such a key one as well. I think we really underappreciate, or the general public really underappreciates, or doesn't really know how poisonous a lot of the materials that we commonly have in our buildings are. And of course, that has huge consequences for the people who are actually in the construction industry. So that's a real benefit that we should be pushing. Next question. Does anyone know what assumptions can be made about the service life of hemp, either structurally or in composite construction? It would be interesting to know about any older examples. Go on, someone's got to have some thoughts on that.
Well, I don't know about actual hempcrete, but there's lots of instances of hemp fibre, not the shiv, in traditional Japanese buildings, which are very, very old. They've got a long history of building earth walls, and they use a lot of rope in their walls for a bit like we use wattle and daub. They use timber and rope, and then in their plasters they use a lot of rope, sort of hemp fibre reinforcement, like little strings that reinforce not actually in the plaster, but tied to the timber on the side to keep the timber. To keep the plaster touching the timber, and these can be very, very old, and they're still intact. So, but it's not hempcrete, but it is hemp fibre in old buildings.
There's a Japanese house, isn't there, that's like 700-year-old, and it had hemp stalk, almost like hemp thatching. But there's an internet rumor that there was a Roman bridge in France in 2,000 years ago made from hempcrete, but I think that's an internet rumor. Sonia may be able to tell us.
If you look at old buildings in the UK, cob buildings which are earth and straw, and the straw is still, they can be 700-800 years old and the straw is still fine. And then if you consider that hemp is a tougher fibre than straw, then you can sort of assume that it's going to last as long or if not longer. But that's all I've got for you. It's a really interesting
question on that note about sort of, we know that separating the fibre and the shiv is really expensive. Are there any examples of construction that doesn't do that keeps the fibre and the shiv together and uses that as part of the construction?
The only one I know is H.G. Matthews, the brickmakers in Bellingdon, grew their own hemp, and they processed it whole and just mushed it up, and then used it as in cob blocks. So clay, what would be clay and straw, but they're clay in the whole hemp plant, and they were super strong. They were really strong, but it was more of a test, because they could grow the hemp. They knew they couldn't process it to a shiv and a fibre, but could they use it whole? And and basically, yes, they did. But whether they're going to do any more, I can't tell you. But yes, you can do that.
There are a couple of people pressing whole stalk into structural elements or sort of replacement timber product, which can be used structurally from hemp full stalk. There was I once took apart a hempcrete building that was Will and I replaced the hempcrete in a building where the hempcrete was made from full hemp stalks, and it was a disastrous affair, wasn't it, for the self-builder?
Oh dear. Well, was that? I mean, that's another fascination that's come up in the chat, is this question of structural performance, and if there are any formats in which hemp, in whatever form it might take, can play a structural role. Are there any more? I mean, Sonia, in the build-up that you showed, it seemed to be, we know it can support itself, but it seemed to be playing a much bigger role than with the sort of timber portal frame build-ups that Will was showing. Are there any insights from that you could share?
I'm sorry, could you just repeat, because there is a small silence with the micro? And
yeah, sorry, it's probably my connection. The question of whether hemp construction can be structural is one that people are finding really interesting and asking a lot about. Your construction seemed to just have the sort of hempcrete blocks without necessarily a supporting frame. How did that work?
Yeah, they are structural in a way. There is different blocks when you buy the Biosys hemp blocks. You have the normal one who just get into like a Lego, and you have others. They have a U shape where you create a concrete beam in it. So it's that the block is not structural in a way, but you have specific species where you build concrete beams beams, yeah, to create windows and to support the roof. The only thing is different that you're not using wooden structure and you filled everything with hemp block, but the block is not structural on its own. You have to recreate a concrete structure inside the hemp specific blocks. So I don't know if it's the right answer that you were looking for, but this is the thing that I could say about it.
More of sort of a hybrid kind of construction then, I suppose. I mean, I think, one of the bits that I really enjoyed out of Paloma's talk was that honesty of, there are some bits of the project that worked really, really well in terms of kind of the natural construction, and other areas, where there were concrete foundations and so on, and a kind of recognition that there were some compromises made, and kind of the commitment to doing, going harder on that, on the natural materials angle in the future. And one final question, because we really are pushing it for time now, but the reusability of hempcrete, how easily can it be recycled? And what's the advantage of hemp over another material like wood chips when we think about sort of the construction and the reusability? Well, I know that you put a bit of an answer in the chat, but that's just such an interesting topic, and sort of, end of life, cradle to cradle, compostability and so on. So just a nice thing to end on.
Well, the only experience I've got of reusing it is when I was at H.G. Matthews and we made the hempcrete blocks. You get some that somebody would drive a forklift into a pallet, and you'd get some that were misshapen and you couldn't sell. And all these blocks we put through a thing called a jaw crusher, which is just two jaws that do that, and it just crushes it into basically shiv with bits of lime on, and we bagged it up in bags, and there's a really nice building where we built a nursery, Earth Dome nursery for the local community there, and we poured it. We put blocks on the roof, as I think I showed in one of my picture, and then over the top of the blocks we poured these crushed blocks to fill in all the gaps and just give one continuous layer over the whole roof. The roof was a very shallow pitch, so it didn't roll off. And so yeah, and the manufacturers who make the Italian blocks, Cennini, they do a very similar thing. Any waste they have from their block manufacturing, they bag up and they sell as a secondary loose fill insulation. So it's just hemp coated with lime. So I suspect if you had to knock down a hempcrete building, if you could keep the hemp clean, if you could keep that away from other materials, then I suspect you could crush it and use it as a loose fill insulation. And then the other question, I think wood chips would work a bit like hempcrete because they do light earth blocks with wood chip. But I think the point about hemp is it's very, very quick growing, very low density. So I think using the wood, chipping up wood would be a bit of a waste when you can use it for other things. And things like wood shavings or straw just don't retain their shape in the mix. They just go to slush. So they wouldn't create all the air pockets that hempcrete does.
It's the carbon sequestration as well, isn't it, of the hemp and the time to harvest, because whether the wood's coming from forestry or stage processing of timber or processing of recycled timber, it's just the time that it takes to sequester carbon through timber is so much greater than hemp. And arguably if it's processed construction timber, then you've got chemical treatments in there from the source material.
Amazing. Well, one sneaky extra final question, because it's just such a good one that came in very late, but why hemp specifically? Maybe each of you, one final thought before we close the event about your favorite thing about hemp.
It's got so many uses. So if we were going to grow lots and lots and lots of hemp to build lots and lots of buildings, the first question you get is, but it's going to displace food crops. Well, it's not actually, because in this country at least, it's grown as a break crop between sowings of wheat. So as people will know, because you're all hemp addicts here anyway, there's just so many different potential uses, and it's such a real transition crop that's going to get us beyond fossil fuels.
I just wanted to say that for me, using this hemp block for that project helped me to not using the same design and conception way of doing buildings, because everything was new. So we have to think all together with the team, the engineers, the constructor, the municipality, everybody was involved in that project. And so maybe that's why I really want to reuse hemp on other projects, because it's full of possibilities to design things in really different way and new way, and to be more inventive in a way, I would say, as an architect. So
the thing that hooked me ever since I built my first hemp building back in 2008, I just saw Tom Woolley in the audience. I bought his book, Hemp Construction, and I designed a little kitchen extension and I built it. And the moment I took the shutters off for the first time and saw the hempcrete behind, I was absolutely hooked. And I was just like, this is the most amazing material. And that from then on, that's it really for me.
Amazing. Well, thank you so much, everyone, for those really wonderful insights, and thank you for your patience as well, as we, as ever, in our enthusiasm, run a little bit over. I'm just going to hand over to Steph, who's going to close us out.
Yeah, just want to say thank you everybody for coming. It's been a real pleasure, and I'm just going to quickly wrap up with what we're doing over the next few months at ACAN. I think there's a slide that goes with this, which will pop up on the screen shortly. So we've got more natural material events coming up, with our next one in January on myth busting. We've got working on live design sessions and also case study projects, so watch out for those. And we're also hoping to arrange a meetup in person soon, probably at Will's house at this rate. So So to help us understand our audience better and highlight the main barriers to using natural materials, we've also got a survey running. So please do participate if you haven't already. The link will be posted in the chat now, and we'll send that out with the Eventbrite. And finally, if you'd like to join us at ACAN Natural Materials, the link to the WhatsApp group will also be posted in the chat now, and we'll go out with the Eventbrite party bag tomorrow. And you can email us as well at naturalmaterials@architectscan.org. So I just mentioned there'll be a follow-up kind of Eventbrite email, which we're calling our party bag, to round up this event with information on the speakers and further resources and contact details. So do watch out for that in your inbox tomorrow if you'd like to do some further reading. And just want to say a really big thank you again to all of our speakers for some brilliant conversation. And thanks everyone for coming, and we hope to see you again soon.